and you didn't have any idea how to find dy dx on a polar curve, but it helped you. It said, hint, use a parametrically defined function where x is r cosine theta and y is r sine theta. So step 1, I'm going to define x to be r cosine theta, but what is r? So x would be a function that is 3 sine of 2 theta times cosine theta. Y would be the function 3 sine of 2 theta times sine of theta. Would you agree with that? If that truly is x and y, then I can rewrite that as a parametrically defined function. If it is parametrically defined, can I find dy dx? It's pretty nasty on this one. Why is it pretty nasty? Product rule and chain rule on the d left. So we'll do it. No derivative should scare you at this point. Dx d theta is left d right. What's the derivative of cosine? Plus right d left. There is a 2 there. My board was being glitchy. Sorry. Any questions so far? We got to do dy d theta. Dy d theta, still a product rule. Left d right plus right d left. So dy over dx, so this is still part A, is, now this is AP. Do I have to simplify anything? No. 3 sine of 2 theta. I may have to match multiple choice answer. I'll cross that bridge when I get there. Cosine theta plus 6 sine theta cosine 2 theta. Oh, still ran out of room. Don't y'all wish your paper could do that? No, that's not right. Sine of regular theta right there. Cosine 2 theta. All over the blue part. I will close that door as soon as it cools off. But for a moment, we're just gonna leave it open. Oh, that was out. Stuck with red. Are y'all okay? -3 sine of 2 theta Sine of theta. I color coded so you know which part's coming from where. 6 cosine theta. Cosine 2 theta. Right? That look right? Let me know if I have any errors in there. Tangent line. What do I need to do the tangent line? X, Y, and M, right? So derivative at pi over 6, first of all. I could do that by hand, and maybe it's a non-calculator question. Maybe I have to. Are y'all okay if we don't? Y'all can unit circle that, right? So you know the cosine of pi over 3 and the sine of pi over 6 and yada, 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 right? So someone with a calculator, just for time purposes, do that for me. With a pi over 6 in, please. The
no, I think dy over dx was like pi over 6.
3 people do it.
No, it's a long way.
I mean, there's a lot of ways you can calculate her, but no, you gotta plug it in.
So it just
You will be okay. You have a fraction bar in your calculator. I do suggest that you use it. Now you could put that thing in y equals and then go plug in pi over 6 so that you only have to type pi over 6 once. But you gotta plug it in somehow. More than one person do it. My first hour, we struggled with some calculator stuff this morning, so more than one do it. I should have just started doing it by hand by the time I... What? Okay, that's my first one. I need the 2 other backups to verify. 2.2.
2.887. I thought you meant like some more answers.
No, I want verification that that is the correct answer. After my first hour, I've been a little more careful, but okay, what's x? What's y? By the way, neither one of those are pi over 6. Why not? That's theta. So what's x and what's y, and how do you know? Plug it in where? For x and y. So do that.
Y is 1.299.
Now, some of you asked, and I actually want to go back and answer that question. Could your calculator have done this for you? Your calculator could have found dy dt and dx dt, and then you could have evaluated. So you could have, if you were really calculator savvy, you could have done a big fraction bar and put dy dt evaluated at theta is pi over 6, and you could have done divided by dx dt evaluated at. Y'all know that evaluated at bar? You put the little... So you see how I write this? You write at theta equals after that bar. Left. Someone let me borrow one of those handy dandy 89. The 84 is different, very different. So I am not going to do the whole thing, but say you wanted to do the derivative of x squared comma x, right, close parentheses. After that, if you put the such that bar, x equals 2, it'll do the derivative of x squared at 2. Like it'll plug in this bar right here. So that's the syntax to type in plug in the number, such that. You see how that's much more mathematical? This calculator is much more mathematical notation than the 84. Sometimes. This did pretty print before the 84 did pretty print. Fractions.
This is pretty out. Like when you type it. Yeah, I like
the 84 stole it from the 89. Yeah, when you hit enter it does. But no, you can't in the line. The line's not big enough. Not enough pixels there, yeah. Okay, that makes sense. So if you ever want to use that, yes, it can. It can do all kinds of things. You just need to practice it. Okay, and what did we get for x? Joseph, did you say you had x? I thought I heard someone saying they had it.
It was 2.2.
Okay. What? 2 point what? 2.25?
Yes.
Like the end? Like there's 9 more decimals. It is. Okay, cool. Just making sure. Why am I just making sure? You gotta make sure if there are more decimals, you go to 3. Okay. So, today we're going to be learning polar calculus. You actually just did some. Don't write this down. This is the BC course description, what you need to know about polar calculus. So the top is the only part that what BC requires. The analysis of planar curves, including those given in polar form, derivatives of polar functions, and finding the area of a region, included the region bounded by polar curves. So that's what we need to know. What you needed to come in with is a knowledge of polar coordinates, r theta, being able to graph polar curves without a calculator if it's a must. Now I will tell you, I've looked at several AP problems. It is a big time rarity for them to make you graph completely by hand. So we would be talking once in a lifetime type question on an AP exam. But we want to be able to do it if it comes up. But it's not something you're not going to have to graph 10 polar curves on the AP exam. You know. Convert points back and forth, and convert equations back and forth. So those are kind of the skills we need. So the first thing we're going to learn is polar slope, which you actually just learned. To do the slope of a polar curve at a point, you are going to define the polar function parametrically, x and y, using r sine theta as y and r cosine theta as x. So you will have to have those formulas memorized. And then it's parametric again, isn't it? A lot of times people wonder why you lump parametric and polar equations together, because seemingly from a pre-cal perspective, they are nothing alike. But from a calculus perspective, do you see why we put them in the same chapter? And vectors. It's like tomato, tomato, polar, vector, parametric. Yes. Okay, so find the slope. This is not the same one, is it? Okay. Find dy dx and the slope of the graph of the polar curve at the given value of theta. Notice it is a unit circle value. I don't know if it's a calculator question or not, but it could go either way because it's a unit circle value. So keep that in mind. It'll be a lot nastier if it's not a calculator problem, but If it's open response, remember you can leave those nasty. If it's multiple choice, you would have to actually do some trig and find the values. So there's two things we're learning today. Pretty much polar slope and the beginnings of polar area. Polar area will take us a couple of days to get the full-fledged discussion, but we'll start it today.
So when we get the homework, what will be due Monday?
The whole homework I give you today will be due Monday. But
okay, so it's not going to be over.
No, it's not like a packet. It's a one page doodad. And then there's another one-page one on Monday and another one-page one on Tuesday. I don't know if I go that far, but you know, it's not terrible either.
It sounds like it's complete as nice.
It's not horrible. For BC calculus, it might be easy. I don't know if I'd call it easy outside of this classroom, but I don't know if anything you do in Cal 2 is easy. In relation to something else, maybe, but they're still calculus. Still have some difficulty to them. But y'all are doing very well with parametric, polar, and well, parametric and vectors. We'll see about polar. Polar. That's because we have. No.
Today do goals.
I can't really say you're doing good with polar yet because we haven't really. Yeah, haven't done anything yet. Except the bell ringer. Okay, so how am I going to find dy over dx? What are you doing? Step 1.
It's in relation to
Find an x and a y value. And I know x is r, which is 3 plus 2 sine of theta. Cosine theta. And y is r. Sine of theta. So dy over dx is okay, good. Left d right plus right d left. Good. Any questions about that nasty derivative there? Make sure you put the y on top, right? Changing y over changing x. Any questions about that part? It's been a while since we've done a derivative of that difficulty level, probably. We okay? Okay, and then left. Oh, I tried to switch colors. I was unsuccessful. Left d right, which is, yes, plus right. D left is the same, right? Correct, because it's the same left-hand function. There may be some simplification that could be done here, but what am I asked to do? At pi over 6, right? So I'm going to plug in pi over 6 in for my thetas, just for fun, as much as I really would rather not. Let's do that by hand, just for fun. Remember, if this for some reason fell non-calculator, what can you do? once you plug in the pi over 6. Leave it. I'm going to do it, simplify a little. At some point, we'll calculator. Okay. Yes, you could just write pi over 6 and place a theta on the open response. They would take it. Multiple choice, which is a lot of times this will fall in multiple choice. You would have to pick out the equivalent answer. Pi over 6 is a 30-degree angle. I know you probably all know this without drawing the picture, but just in case. So sine of that 30-degree angle is a half. Cosine of that angle is radical 3 over 2. Figure it's good for you to occasionally see me do a unit circle problem. Okay, the bottom, I switched colors on you, sorry. Cosine of theta was radical 3 over 2, is that right? These are both 4. Everyone agree with that? 3 plus 1, which is 4. So I get 2 radical 3 on the top, on the left of the top, plus radical 3 over 2. On the bottom, 4 times negative 1/2, which is negative 2, plus 3 over 2, just 3 over 2, which is already rationalized. That's nice. A very likely multiple choice. Math people are lazy. Very likely they multiply everything by 2. Why would you do that? No more fractions. Very likely that you see them do that on multiple choice, which means you get 5 radical 3 on the top, negative 1 on the bottom, which is negative 5 radical 3. I hope I don't have to do that very many times, but if I must, I will. Again, the case we would be talking, the scenario we would be talking here would be matching multiple choice answers. If it were non-calculator, multiple choice would be a nasty one. The calculus part wasn't nasty. The trig part was the nasty part. Tedious would be the correct word for that. Not hard, but tedious. Any questions about that? Okay, find the points of horizontal and vertical tangency. How in the world do you think you would do that? Good. Find dx dt set equal to 0. Find dy dt set it equal to 0. Everyone agree with that? Which one's horizontal tangents? The top, which would be dy. Everyone agree? So first I need to find y. Guess I need a sine r sine theta. Left, d right. What is the derivative of negative 2 cosine theta. 2 sine theta. Everyone agree? We do have to simplify a little bit. Where? You can take out a 2, but cosine squared, negative cosine squared plus sine squared is not 1, unfortunately. No, because then you'd have minus the other way. What I will need to do if I want to solve this by hand, which we're about to find out if we even can. I don't remember. I can't remember if this is one I can solve by hand. But if I can solve it by hand, that better be a cosine. Would you agree with that? Because I can't solve it with more than one trig function involved. How could I change 2 sine squared into a cosine function? It's been a while. So I get 2 cosine theta minus 2 cosine squared theta plus 2 minus 2 cosine squared theta. So I get negative 4 cosine squared theta plus 2 cosine theta plus 2. I would divide everything by negative 2. Why would I divide everything by negative 2? Nobody likes negatives in front of quadratics. And then we have a greatest common factor. This does not factor, so therefore this is a calculator problem. So I didn't know that till I got here, but it was good for you to practice some trig solving. You'll know why it doesn't factor. 2 and 1 don't add to give you 1. So because of that, it does not factor. So you might go way back up there and set it equal to 0 before I messed it up. It's up to you. So calculator. Someone put that in a calculator and find when that equals 0. I wouldn't. But you can do whatever you want. Yeah, polar would be very difficult. So no, I would use x for theta and put it in my y equals and just find when that crosses the x-axis. Because I just want to know when that equals 0, right? Find the intersections. Really quick, let me read the question again.
Find the points.
Points. Second format, I don't remember which one's format. Look up there at the top, you see it? Axes on. Yes, you would write this as cosine of theta parentheses squared. Look at that. That's how you type that in here. Never? I think that's plausible. Does that quadratic formula even have real answers? I think that quadratic formula doesn't even have real answers, does it? No. So what does that mean?
No, I doesn't have any horizontal tangents.
It's not possible. I divided everything by negative 2, yes. Oh, I see what uh-oh. Thank you. What is he noticing that I didn't notice? Both of those should be minus, shouldn't it? Oh, you're going to get some solutions now, aren't you? Makes more sense. Something very important that I said. It was important for a reason. Did y'all hear me say, as soon as I said I can't do this by hand, go back to the part I didn't mess up? Did y'all hear me say that? Why did I say that?
Because you kind of messed up.
Because I messed it up. I didn't know I messed it up. I could pretend I knew, but I didn't know I messed it up. But it hasn't set any bounds, so theoretically we're going to get a lot of answers. However, time out. What did it ask for? Points of tangency. Would you agree at some point after you go from 0 to 2 pi, those values are going to give you the same sine and cosine values from then on? So the x and y coordinates will be the same. So for me, I'm going to do 0 to 2 pi because all I need are the answers. Does that make sense? So all I need are the answers from 0 to 2 pi. So what do you get? 0?
Just over 2. The next one is 2.094.
Which I'm going to back up for a moment. You can keep finding them in the calculator, but I think I can find them by hand now. Probably faster. 2 cosine. Now that we've got it factored, right? Or 1 and 1. Minus plus. Cosine is negative 1/2. Cosine equals 1. So cosine is 1 at 0. That's why you're getting 0 as an answer. And when is cosine negative 1/2?
No, I mean, 2 pi.
Okay, good. 2 pi over 3 and 5 pi over 3. You can do this in the calculator. That's great, but it turns out I could do it by hand. You can, but sine and cosine are both going to be the same. The y value and the x value are going to be the same at 2 pi as they were at 0. Would you agree with that, Joseph? Find the x value by plugging in those points into the x, which I haven't even written down yet. By the way, x is 2 minus 2 cosine theta. Cosine theta. So plug all of those into x and y. Those are your points. We will finish that tomorrow. I do want to introduce area. We will not get finished with area, but I want to introduce it, and we only have 5 minutes, so I'm going to stop and do that really quick. We'll finish that problem on Monday, though. I want to remind you really quick how you find area of a piece of a circle. Stay with me for the next 5 minutes. Would you agree this is how you find area of a sector of a circle in general? Theta over 2 pi or theta over 360. You might remember a formula like that for the ACT. It does simplify down to this formula. Do you agree with that? So if the pi's cancel. If I want to find the area of a part of a circle, I would multiply 1/2 times the radius squared times the angle. Well, if I want to find the area enclosed in a polar graph, I would want to take teeny tiny little pieces of circles, areas of sectors, and add them up. It may not be a circle all the way around, but for part of it, it will. Which gives me this formula. The area enclosed by a polar graph is the integral from angle 1 to angle 2, depends on where we're going, of 1/2 r squared d theta. We're doing teeny tiny angles, finding teeny tiny areas of sectors of circles, and adding a bunch of them up. Sounds like an integral to you, doesn't it? And that's how you find the area of a polar graph. D theta refers to a thin little pie-shaped sector of the circle.
So was that other equation just what?
How to get here. area of a sector of a circle. This is area enclosed by a polar curve. This is the important slide. The last slide was the why. This is the how. So if I want the area enclosed by this graph, I'm going to do little sectors of circles all the way around. No, when I get over here, they look more like this, right? They look different. But the cool thing is I do 1/2 r, which is 2 plus 2 cosine of theta squared d theta. This one tells me the endpoints. As you can imagine, one of the difficulties will be finding those endpoints if it doesn't tell us the endpoints, and that's where polar graphing comes into play, both calculator and non-calculator. That's how you do that. That is the area of that polar graph. Any questions about that? Good question. We don't know that yet. So we don't know everything yet, but we have a little introduction. Polar area of polar graph. More about that later. Well, you would find that the integral. Now, that integral for today, I'm going to say go ahead and do the calculator. There is actually a way to do it by hand, but it involves trig identity.